day, viewers of TV Eskwela Davao de Oro, especially to the grade 11 students out there. By the way, I'm Salvictorino, Reguya from Laak National High School, your teacher in subject Earth and Life Science. Due to the pandemic that we are experiencing right now, we are not able to have face-to-face learning. But it is not a hindrance for us to continue with our academe. Therefore, the Department of Education prepared different learning mode delivery. And one of these is the TV broadcasting. Before we start, kindly prepare the following necessary materials that you can see on the screen: module, pen, and paper. Our lesson for today is all about the Earth's internal heat. At this point, let us check your prior knowledge. Please open your module on page 5. As you can see, there is a direction stating that you are going to choose the correct answer. Number 1. Why does the radioactive decay play a very important role in Earth's internal heat? Letter A. Radioactive element can be found anywhere in the planet. Letter B. When the radioactive element decays, it produces heat. Letter C. Spontaneous nuclear disintegration of radioactive elements produce thermal energy. Letter D. All of the above. If your answer is letter D, you're right. Number 2. How does the conduction in the surface of the Earth affect the temperature of our atmosphere? Letter A. Air molecules come in contact with the warmer surface of the land and ocean, resulting to the increase of its thermal energy. Letter B. Air molecules come in contact with the cooler surface of the land and ocean, resulting to the decrease of its thermal energy. Letter C. Air molecules does not come in contact with the warmer surface of the land and ocean, resulting to the increase of its thermal energy. Letter D. Air molecules do not come in contact with the cooler surface of the land and ocean, resulting to the increase of its thermal energy. Is your answer letter A? Very good! Air molecules come in contact with the warmer surface of the land and ocean, resulting to the increase of its thermal energy. Number 3. How does the convection in Earth's mantle affects the formation of landmass like volcano and mountain? Letter A. Heat tries to escape in the interior of the Earth. Letter B. Collision and separation of tectonic plates happens due to the slow motion of convection cells. Letter C. When the warm material in the mantle rises up to the surface, it will cool and sinks. These cooled materials will eventually be turned into landmass. And letter D. All of the above. If your answer is letter D, perfect! All of the above. Number 4. What is produced by the radioactive decay of isotopes in the mantle and crust? Letter A. Radiogenic heat. Letter B. Primordial heat. Letter C. Superheating. Letter D. Heat from the sun. If your answer is letter A, nice one! Radiogenic heat. Number 5. This refers to the heat left over from the formation of the Earth. Letter A. Radiogenic heat. Letter B. Primordial heat. Letter C. Superheating. And letter D. Heat from the sun. The answer is letter B. Very good! Number 6. How much is the approximate terawatts in the flow of heat in Earth interior to its surface? A. 41 terawatts. B. 43 terawatts, C. 47 terawatts, D. 49 terawatts. The answer is letter C. Very good! 47 terawatts. Number 7. Which of the following is the outermost layer of the Earth? A. Crust, B. Core, C. Discontinuity, D. Mantle. The answer is letter A. Crust. Very good! Number 8. Which of the following stores magma and located in a region just beneath the crust all the way to the core? A. Crust, B. Outer core, C. Inner core, and D. Mantle. The answer is letter D. Mantle. Very good! Number 9. What heat transfer of fluid in the Earth's interior results to the movement of rocky mantle up to the surface? A. Convection current, B. Conduction, C. Insulation, and D. Radiation. If your answer is letter A, that's correct! Convection current. Number 10. Which of the following are boundaries between the three major layers of the Earth? A. Arches, B. Discontinuities, C. Poles, and D. Plates. The answer is letter B. Discontinuities. Brilliant! I think we're ready. So now, let's proceed to our main topic, which is the Earth's internal heat. If you think of a volcano, you know Earth must be hot inside. The heat inside of our planet moves continents, builds mountains, and causes earthquakes. But where does all this heat inside the Earth come from? Let's figure out. Sources of heat in our planet can be identified as primordial and radiogenic heat. During the early formation of the Earth, the internal heat energy that gradually gathered together by means of dispersion in the planet during its few million years of evolution is called primordial heat. The major contribution of this internal heat is the accretional energy, the energy deposited during the early formation of a planet. The core is a storage of primordial heat that originates from times of accretion, when kinetic energy of colliding particles was transformed into thermal energy. This heat is constantly lost to the outer silicate layers of the mantle and crust to the convection and conduction. That's correct! On the other hand, the thermal energy released as a result of a spontaneous nuclear disintegration is called radiogenic heat. It involves the disintegration of natural radioactive elements inside the Earth, like uranium, thorium, and potassium. Uranium is a special kind of element because when it decays, heat produced. The flow of heat from Earth's interior to the surface, and it comes from two main sources. First, the radiogenic heat produced by the radioactive decay of isotopes in the mantle, crust, and the primordial heat left over from the formation of Earth. Radioactive elements exist everywhere on Earth in a fairly significant concentration. Without the process of radioactive decay, there would be fewer volcanoes and earthquakes, and less formation of Earth's vast mountain ranges. This time, let's have a short activity. Turn your module on pages 9 to 10. The direction for your first activity is to label the structure of the Earth. And for your second activity instruction, is you're going to identify the sources of internal heat by writing RH for radiogenic heat and pH for primordial heat. I'll give you time to do this activity. Very good! Okay, let's check your work. Let's check the first activity. In labeling the structural parts of the Earth, crust is located outer part of the Earth, followed by mantle that lies below the crust. And the last one is the core. It's located at the center of the Earth. Okay, those are the parts of the structure of the Earth. For the next activity, the answer for the number 1 is what? That's correct. It is RH or radiogenic heat. How about number 2? Precisely, it is pH or primordial heat. Next, number 3. Very good. That is pH or primordial heat. For number 4, that's great. RH or radiogenic heat. For the last activity, encircle the 10 words listed below. Words may appear straight across, backward straight across, up and down. You can check your answer on the answer section or page. Sources of heat and heat transfer. Where it all started. Both sources of heat, whether primordial or radiogenic, undergo heat transfer and it plays an important role to the continuous changes and development of our planet. In connection, another part of this module describes the heat transfer in the Earth. Three processes can transfer heat. The first, conduction, convection, and radiation. So, conduction governs the thermal condition in almost entire solid portion of the Earth and plays a very important role in the lithosphere. Its processes happen in Earth's surface. Conduction is one of the three main ways that the heat energy moves from place to place. Technically, it can be defined as the process by which heat energy is transmitted through collisions between neighboring atoms or molecules. Heat from Earth's core and radiation from the Sun is transferred to the surface of the Earth by conduction. Contact of the atmosphere with these warm surfaces transfers thermal energy, which then heats up the rest of the air through convection. Convection involves transfer of heat by the movement of mass, which is more efficient means of heat transport in the Earth compared to pure conduction. In convection current, the mantle of the Earth moves slowly because of transfer of the heat from interior of the Earth up to the surface. At those edges, it becomes dense by its exposure from the heat and sinks into the earth and ocean trench. This starts the formation of volcanoes. The last one is radiation. Radiation is the least important mode of heat transport in the earth. Why? The process of heat exchange between the sun and the earth. Through radiation controls the temperatures at the earth's surface. Inside the earth, radiation is significant only in the hottest part of the core and also for the lower mantle. Convection in the air then spreads out the thermal energy throughout the atmosphere. Now, let's answer what is it? Activity 5 entitled Fill Me Up on page 12. Use the word bank to fill in the gaps in the passage below. And don't forget to write your answers on a separate sheet of paper. Are you done? Good! Let's check your work. Let's complete the statement what is given. The surface layer of the earth is called the good crust. Next, this layer is broken up into the pieces called nice one, earth plate. Heat rising and falling inside the mantle creates current called convection current. That's correct. The convection current move the plate tectonics. That's correct. This movement is known as earthquakes. The movement of the Earth's plate causes earthquakes and volcanoes. That's correct. There are more activities that you can find in your module. So, continue answering, then check if your answers are correct by using the answer keys provided. If you have some questions, please let me know by sending it to our Facebook page, TV Eskwela, or you can contact your teacher. Thank you for watching and listening. I hope that you enjoy our discussion. Again, I am teacher Salvictorino Reguya from Laak National High School, Laak South District. Always remember, dito sa TV Eskwela, sa pag-aaral, sama-sama. Bye-bye!